Hi guys, welcome to today's video. It's a grade 12 differential calculus video. It should be a long video, so get your snacks and settle in. We're going to start with differentiation from first principle. First, what does the term differentiate mean? Differentiate is the process of finding the derivative of a function. And the notations are as follows. You can write it as f prime of x, or y prime, or dy dx, or df dx, or d dx of f of x, or df of x, or finally dx y. They all mean the same thing, that is the differentiation or the derivative of a function. Now let's take a look at an example as to how to differentiate using first principle. The question states, determine the derivative of f of x is equals to 1 over x plus 3 using first principles. F prime of x is equals to limit as height approaches 0 of f of x plus h minus f of x divided by h. How do I do this now? Look at the limit, the formula with the limit. It says f of x plus h. Where I see f of x plus h, I go to my function. On my function, wherever I see x, I substitute in x plus h. That means I replace x on my function, f of x, with x plus h. And now going back to the limit formula, where I see f of x, I substitute in f of x as it is, and the height is the one that approaches 0. We're not going to touch that until the very last step of the question. Now, doing everything I've said, where there's x on f of x plus h, I've put x plus h, and hence I have the limit as height approaches 0 of 1 over x plus h plus 3 minus 1 over x plus 3, all divided by h. And now simplifying that, the first thing I need to do here is to make sure that both my expressions have the same base. That is the numerator expressions. The h, I'm still leaving it as it is. Both my numerator expressions have the same base. And that means I'm going to multiply each expression by the base of the other. X plus h plus 3, I'm going to multiply it by x plus 3. And because what I do at the bottom, I must do at the top. Also the one I'm going to multiply it with x plus 3. Going to the right hand side of the negative sign, the x plus 3 now, I'm going to multiply it with x plus h plus 3. And also the one on the numerator, I must do the same as well. And simplifying that numerator a little bit better, I get x plus 3 over x plus h plus 3 multiplied by x plus 3 minus x plus h plus 3 over x plus 3 over x plus h plus 3, all divided by h. Now, if I look at my numerator, I can see that both my numerators have the same denominators, and mathematically we know that means that we can add or subtract the numerators with the same base, because the bases are the same. And doing what I've just told you, I get x plus 3 minus x minus h minus 3, all divided by x plus h plus 3 over all divided by x plus h plus 3 multiplied by x plus 3, because that's the same base, all divided by h. And simplifying further the numerator, I get negative h over x plus h plus 3 multiplied by x plus 3, all divided by h. Now, that division expression seems too complicated, but I know mathematically that if I'm dividing by something, that is the same as multiplying it by the inverse of the denominator. That means that h that is dividing everything, I can multiply it, but when I multiply it, it's no longer h, it's now 1 over h, or the inverse of h rather. And doing what I've just told you, I get negative h over x plus h plus 3 multiplied by x plus 3 multiplied by 1 over h. And now I know that there's an h at the numerator and this h at the denominator, and those two h's are going to cancel each other out, leaving me with 1 at the numerator and the negative sign in front of the expression, as you can see, all divided by x plus h plus 3 multiplied by x plus 3. And now this is where now I can substitute in the 0 for h, because h is approaching 0, and doing that, I get the following expression: -1 over x plus 0 plus 3 multiplied by x plus 3, and that's going to leave me with 1 over x plus 3, x plus 3, and finally that's going to be 1 over x plus 3 all squared. And just like that, you've differentiated the function f of x is equals to 1 over x plus 3 using first principles. If you got lost somewhere along the way, feel free to rewind the video and make sure that you get all the explanations, because this part is pretty crucial. You're gonna get a question like this in an exam and it's gonna have a lot of marks. Now let's move on to the general rule of differentiation. It's like a shortcut of differentiating a function. If the question doesn't state use first principle, you should usually use this rule because it's way quicker and it takes less time and less of your page and less of your ink on your pen. And the general rule states d dx of x squared is equals to n multiplied by x. That means the exponent, I'm going to multiply it into the base. And now the exponent, I'm going to subtract 1 from it. That's what that general rule means. Second rule is that derivative of a constant is 0. That means d dx of a constant is equals to 0. A constant is a number without an x or any other variable next to it, and the derivative of that function will always be 0. Now, we know that maths is not a theoretical subject. It needs you to practice. So let's take a look at some examples. And the example states, differentiate the following function. A, y is equals to 2x squared, b, y is equals to 13x, c, y is equals to x to the power 4 minus x plus 1, and d, y is equals to 2x squared plus 3x plus 4. Let's start with y is equals to 2x squared. Now, first, I know that 2 at the power or at the exponent needs to come down and multiply the base first, which is the 2x. And 2 multiplied by 2x will be 4x. And next, I need to minus 1 from that power, and hence it will now be 1. After writing down everything I've just told you, that is 2 multiplied by 2x squared to the power 2 minus 1. That will leave me with 4x to the power of 1. And we don't bother by writing the 1 because anything, it is to the power of 1. Moving on to the next example, which is 13x. First, I know the power of that x is 1. So that 1 needs to come down and multiply the 13. And that will give me what? 1 multiplied by 13x into the power of 1 minus 1. And that will give me 13, because x to the power of 1 minus 1 is x to the power 0. And anything to the power of 0 is 1. And hence 13 multiplied by 1 will be 13. Moving on to c. C is y is equals to x to the power 4 minus x plus 1. And first, the 4 needs to come down to multiply the base. So I will have 4 times x to the power 4 minus 1, because I need to subtract the 1 from the power. And again, for the negative 1, the 1 needs to come down and multiply the 1. And we need to subtract 1 from the exponent, and then the 1 is a constant. And at the beginning of this subsection, I've told you that the derivative of a constant is 0, and hence 1 is a constant, and hence its derivative will be 0. And simplifying that, I get y prime is equals to 4x cubed minus 1. Moving on to the last question, which is y is equals to 2x squared plus 3x plus 4. And again, for 2x, the 2 needs to come down, multiply by the first 2, and it will be 4x. And then we need to minus the 1 from the power, and so on. And doing everything I've just told you, I will have the following expression. And note that the derivative of 4 again is 0, because 4 is a constant. It doesn't have a variable x. And finally, that derivative comes down to 4x plus 3. Moving on to find the equation of a tangent to a curve. First thing I need to do is to differentiate the function. Second thing, substitute the x-coordinate of the given point into the derivative of the tangent to get the tangent rather. And third thing, I need to substitute both the calculated gradient and the given point coordinates to the equation of a straight line y is equals to mx plus c, and make y subject of the formula, and I'll have the equation of the tangent. Now let's see this in practice. The example says, determine the equation of a tangent to a curve defined by f of x is equals to x to the power 4 minus 5x cubed plus 2x squared at a point 5:50. Let's see the solutions. We know that the f function is defined by x to the power 4 minus 5x cubed plus 2x squared, and the given point is 5:50. First thing, I find the derivative of a function, and the derivative of a function is given by 4x cubed minus 15x squared plus 4x. Again, please make sure you know how to derive. Substituting in the 5 on the derivative, I get f prime of 5 of 145, and I know that 145 is my tangent, or is the gradient of the tangent. Next step, I'm gonna write the equation of a straight line as follows: y is equals to mx plus c, and then substitute in the given point and the gradient that I've calculated. I'm gonna get 50 is equals to 145 multiplied by 5 plus c to get a c value that equals to negative 675. And now substituting everything back into my original equation, which is y is equals to mx plus c, I get y is equals to 145x minus 675. That's pretty simple. Let's move on. Notations of the second derivative now. Everything we've been doing so far is first derivative. Now we're going to concern ourselves with second derivatives, and the notations are as follows. You can write it as f double prime of x, or y double prime, or d dx, dy dx, or d squared y dx squared. They all mean the same thing, which is the second derivative of a function. The second derivative is simply the derivative of the first derivative. That means we derive the function twice. Let's take a look at an example. It says, calculate the second derivative of y is equals to 8x cubed plus 2x squared plus x plus 1. The solutions are as follows. I know that y is equals to 8x cubed plus 2x squared plus x plus 1. That is my given function. And hence the first derivative represented by y prime is equals to 24x squared plus 4x plus 1 plus 0. And the second derivative now will be 48x plus 4 plus 0, and hence the second derivative is 40x plus 4. Pretty simple. Let's move on to stationary points. This is under the subsection sketching graphs. Now, what is a stationary point? A stationary point is the point where the tangent of the graph is 0. Usually these are your turning points, also called local minimum or local maximum. To find the coordinates of the stationary points of f of x, we need to follow the following steps. First, determine the first derivative, which is f prime of x, and let f prime of x equals to 0 and solve for the x coordinates. And next, substitute the x coordinates back into the original function f prime of x. Now, let's take a look at an example to see what I was talking about earlier. The question says, find the stationary points of the function f of x is equals to x cubed minus 6x squared plus 9x minus 4. First thing, I'm gonna find the first derivative, which is 3x squared minus 12x plus 9. Now, finding the x coordinates, I'm gonna say f prime of x is equals to 0. That is 3x squared minus 12x plus 9 is equals to 0. And solving for x, I get x is equals to 3, or x is equals to 1. Now that I have my x coordinates, I need to substitute them back into my original equation to get the y values. That means that f of 3 is equals to 3 cubed minus 6, 3 squared plus 9 multiplied by 3 minus 4. And that will give me a y value of negative 4. And f of 1 is equals to 1 cubed minus 6, 1 squared plus 9 multiplied by 1 minus 4. And that will give me a y value of 4. Hence, now the coordinates of my neutral points now will be 3 is to negative 4 and 1 is to 0. Let's move on to sketching cubic graphs. How to sketch cubic graphs? We need to follow these steps. First, observe the sign of A. It tells you the general shape of the graph. If A is greater than 0, then the graph goes from bottom left to top right. And if A is less than 0, now the graph goes from top left to bottom right. Second, find the y-intercept by letting x is equals to 0. and determine the x-intercepts by factorizing the cubic function. If necessary, find the coordinates of neutral points by letting f prime of x equals to 0 or the first derivative equals to 0 and solve for x. Determine the y coordinates of the turning point by substituting the x values into the original graph f of x. Finally, plot the points and draw a smooth curve. Now, let's take a look at an example to illustrate this. The example says, sketch the graph of f of x equals to x cubed minus 6x squared plus 11x minus 6. If you were told that x minus 1 is a factor of f of x. First step, find the y-intercept. That is, this is just letting x equals to 0. F of 0 is equals to 0 cubed minus 6 multiplied by 0 squared plus 11 multiplied by 0 minus 6, which gives me negative 6, and hence the y-intercept will be given by 0 is to negative 6. Now let's go and find the x-intercepts by now letting y is equals to 0. I was told that x minus 1 is a factor. If I factor out x minus 1, I will be left with an unknown quadratic formula, and hence I've written down the general formula of quadratic formula there, which is ax squared plus bx plus c, and that whole thing is equals to my original function f of x, which is equals to x cubed minus 6x squared plus 11x minus 6. Now, for this part of the equation, or for this part of the question, we're only gonna focus on the left-hand side of this expression. The right-hand side, ignore it for now. We're gonna use it at the final stages of this particular question. First, I'm gonna multiply the x minus 1 into the general quadratic formula ax squared plus bx plus c to give me ax cubed plus bx squared plus cx minus ax squared minus bx minus c. The right hand side, again, I'm leaving it alone. I'm only focused on the left hand side. Now, grouping the like terms, I can see that ax cubed is alone. There's no other value with an x cubed. But the value with x squared, there are two. And I've highlighted them in red. That is bx squared minus ax squared. And I've grouped them together and I've highlighted them in red, as you can see. Moving on to cx, again, the values with x are 2, that is cx minus bx, and I've highlighted them in green, as you can see. And finally, the c, which is also alone, there's no other constant. Again, the right hand side, I'm going to leave it alone for now. And simplifying that a bit further, I get ax cubed plus b minus a, x squared, I've factored it out. Again, on the c minus b, I've factored out x, as you can see, minus c. And I've left the right hand side alone still for now. Now looking at that now, at the left hand side and the right hand side, by observing, I can see that the one with the cube, ax cube, should be equal to the one at the cube at the right. That means a should be equal to 1 because the x cube is multiplied by 1 to get x cube. And hence a is equals to 1. By comparing. Now let's go and look at b minus a. B minus a should equal to whatever has an exponent of x squared, because b minus a also has x squared. And hence b minus a should equal to negative 6, as I've written down now. Now I already know that a is equals to 1, and hence b is equals to negative 6 plus 1, solving for b, and hence b is equals to negative 5. And now I'm going to look at c minus b. C minus b, we multiply by each by x, and at the right hand side, the only other value that's multiplied by x is 11, and hence c minus b should equals to 11. And solving, because I know what b is, solving for c, I get c is equals to 11 minus 5, and c is equals to 6. Now, for that quadratic expression that it is general, it can be a little bit more specific now because I know the values of a, I know the values of b, and I know the values of c. Substituting back that into the quadratic equation, I get x minus 1 multiplied by ax squared plus bx plus c, and I'm going to substitute in the a, b, and c that I found. and I'm gonna get x minus 1 multiplied by x squared minus 5x plus 6. And now x minus 1 is already factorized, but x squared minus 5x plus 6, I also need to factorize it. And that will leave me with this following expression, x minus 2, x minus 3. And I need to equate them to 0 because I'm trying to find the x-intercepts. Hence, x is equals to 1, or x is equals to 2, or x is equals to 3. And now I have my x-intercepts coordinates. 1 is to 0, 2 is to 0, and 3 is to 0. Moving on to the next step, I'm just going to clear out everything. I'm not done with the question, but I'm just going to clear out the steps and only leave the details that are important. Now I'm going to find the turning point. To find the turning point, I know that I need to find the second derivative rather. I know that the first derivative is 3x squared minus 12x plus 11, and hence, to find the turning point, I need to let the first derivative equals to 0. And doing that, I get 3x squared minus 12x plus 11 is equal to 0 and solve for x. That expression is not factorizable by the normal factorizing method, and hence we're going to use the quadratic formula. There is the quadratic formula. I've introduced it, and substituting in everything, I get x equals to negative 12 plus or minus square root of negative 12 squared minus 4 multiplied by 3 multiplied by 11, all divided by 2 multiplied by 3, and that will give me x values of x is equal to 2,57 or x is equal to 1,42. And I'm gonna now substitute those two x values into my original f of x function. So f of 2,57 is equal to 2,57 cubed minus 6 multiplied by 2,57 squared plus 11 multiplied by 2,57 minus 6, and that will give me a y coordinate of negative 0,38. Doing the very same thing with the y 1,42x value, f of 1,42 is equal to 1,42 cubed minus 6 multiplied by 1,42 squared plus 11 multiplied by 1,42 minus 6 to give me a y coordinate of 0,38. And now I have the coordinates of my turning point as 2,57 is to negative 0,38 and 1,42 into 0,38. And now I can finally sketch my graph. You can see it on the bottom right corner. That is how you should draw your sketch. Moving on to the application of differential calculus. First, we're going to define what is an optimization problem, or what are optimization problems. These are problems that involve finding the minimum or maximum values of a function under given conditions. How do we find the optimum point? First, we need to let f prime of x equal to 0, or the first derivative equal to 0, and solve for x to find the optimum point. To see whether the optimum point at x is equal to a is a local minimum or a local maximum, we find the second derivative of the function. And if the second derivative is greater than 0, the point is a local minimum. And if the second derivative is less than 0, the point is a local maximum. Now let's take a look at an example. It says, a farmer wants to build a rectangular chicken pen against one side of her barn. She has 120 meters of chicken wire and will use the barn wall as one side of the pen. So she only needs to fence the other 3 sides. Calculate the length and the width of the pen that gives the largest possible area for the chicken. And that situation is represented on an orange diagram, as you can see on the left hand side. Now let's take a look at the solutions. First, I know that the total chicken wire available is 120 meters, and that should equal to 1 width, because the other width is going to be covered by barn wall plus 2 lengths, and that will give me 120 is equal to w plus L, and now making width the subject of the formula, I get width is equal to 120 minus 2L. The length, I'm going to leave it as it is. I'm not going to try and simplify it because it's already in length. I'm just going to leave the length as it is and write down the area formula for a rectangle. area is given by width multiplied by length for a rectangle. And for width, I'm going to substitute in the width that I've calculated, which is 120 minus 2L, all multiplied by L. And hence I will get an area of 120L minus 2L squared. As you must have noticed, my area is represented in terms of length. Now, I need to derive that formula or find the derivative of that function that represents the length. And that derivative will equal to A prime is equal to 120 minus 4L. Now, equating that to 0 and solving for L, I get 0 is equal to 120 minus 4L, and that will give me an L value of L is equal to 30. And that is my length. Now, I know that width is equal to 120 minus 2L. That is my formula for my initial formula that I've constructed. I need to substitute in the length that I found here to get the width. And substituting in the 30, I get width is equal to 120 minus 2 multiplied by 30, which gives me a width of 60 meters. Now, I need to check whether these values are really the local maximum, because I need maximum value here. So to do that, I need to first find the second derivative. I know that the second derivative of the highlighted function is -4. Now, because it's negative, and I know from the start of this subsection, I've told you that if the derivative is less than 0, then that point is a local maximum. And hence, I know that that width and that length are maximum. And hence, I can write down the conclusion and say, length is equal to 30 and width is equal to 60 meters. And that brings us to the end of this lesson. Thank you for watching. To support the channel and help more students access free lessons, please like the video and subscribe if you're new to the channel. For additional learning materials and updates, visit our website using the link in the description below. Keep studying hard and I'll see you in the next one. Cheers.